Now I want to dig into state space models and hybrid architectures, which you touched on, Tyler. The Granite 4.0 release introduced a hybrid architecture that combines state space models with transformers, and that sounds important too. But maybe I've gone too far. Maybe we should start with digging a bit more into what state space models are first.
Yeah. State space models are a really important family of models, even pre AI usage, right? So if you go back to the 1960s, these are being used in space flight control, right? They've been used in population studies and economic modeling for a long time. The core construct is that you have an input signal that you map onto a hidden or latent state space with one set of equations. And then you have a second set of equations that translate that state into an output that's observable, right? So there's lots of different ways that you can construct a state space model to represent different problems. What's happened over the last 10 years or so is that state space models were investigated as part of the deep learning kind of revolution. Is how do you construct your matrices for state space models to better model different tasks without as much kind of classical feature engineering approach to it, right? So that was one important thing. But then there's a couple of researchers at Carnegie Mellon and Princeton who really kind of drove this home over the last 5 years or so, right? So there's a great set of papers. I invite everybody listening who wants to learn more to look up the work here on Mamba and structured state space models and things like that. There's a series of papers from 2021 all the way up to 2025. Still working on it. That introduced some really great optimizations inside of state space models to make them appropriate for sequence transformation and language modeling tasks, right? So you get this evolution of structured state space models, your S4 paper, and then you go into structured state space models with selection and computation by scanning, your S6, which turns into, hey, that's a lot of S's, sounds like a snake. Now we've got Mamba. And the Mamba architecture really optimizes state space models for the kind of compute profile that's needed to be relevant for the language model tasks that we're applying here. And so some great optimization work that happened there, some great mathematical insights into the matrix properties of those. And I won't be able to do those full justice here, but really, really interesting work. That kind of accumulated into the Mamba and Mamba 2 language model blocks. That IBM pulled in to the Granite 4H series models, right? So composition here, you've got a 9-to-1 ratio of Mamba layers to attention layers in the Granite 4H family. So quite a bit of state space model in that hybrid. Those are, like I said earlier, those are linear context scaling. They are the Granite 4H models are no positional embedding, so they have in the data set out to 512K context represented in the samples. They're validated out to 128K. The IBM team says theoretically you should be able to push it past that, right? Some really great long context performance. I think one of the key measurement points in the release notes are if you take 8 sessions at 128K context on a micro, so a 3 billion parameter model, you get about a 15 gigabyte of memory usage versus about 80 on a pure transformer architecture, right? So some really great context reduction. Which means that on more constrained devices on the edge, you can make use of more useful context in RAG workflows, in multi-turn workflows, and things of that nature. Just to close here, Shirish had mentioned IF eval. That's a really great benchmark for instruction following, right? Structured output tasks. The other things that Granite scores really well on is the Berkeley for function calling leaderboard, specifically BFCLV3. That it shows up in the top 5 as we sit here recording. Among a bunch of other frontier models and hundreds of billion parameter models, even at, for the small, 32 billion parameter footprint. So really, really punching above weight class there.